get started. And I want to thank you all for coming today for the Maricopa County Liaison. I'm Elijah Williams with EPS Group. I host these events. And we'll go ahead and start with announcements. Justin, Amerigo, do you guys have any announcements you'd like to make? I know we're in full swing and trying to get roads and streets wound up.
Yeah, we've got roads and streets well underway. So registration's open, sponsorships are available, booths are available. So obviously we're out of the gate early, but really looking forward to it. Roads and Streets this year will be back at El Conquistador in lovely Tucson, Arizona. And it will be September 28th, 29th, and 30th. And we'll also be holding our golf.
I think we just lost you, Justin. Yep.
Yes, so I'll finish the sentence. We will open up with our golf tournament again at Roads and Streets. So information about that is forthcoming. We're trying to put the final finishing touches on our course information.
Okay. And that's in late September.
Yes.
All right. Any other announcements today for this group?
I'll just, we have a number of positions open, project manager position, assistant division manager in our transportation systems management group for traffic. So we are desperate, just as everybody is, in terms of hiring and getting people in the doors. So spread the word.
Okay. Well, it is a tough market to hire in right now, so we'll spread the word, but I also wish you the best of luck. It's a tough place to hire, particularly people with skills and experience. Well, I'm gonna go ahead and we'll do some introduction. I've already introduced myself. Why don't we start with those who are attending in person, if you guys would like to introduce yourselves.
I'm Matt Wilson, formerly with the city of Phoenix, now with Burgess and Eiffel. So rejoining the consulting community here.
Good morning. This is Sanjay Paul with HDR.
Morning, guys. Glad you are holding down the fort there in person, along with Marigo.
Yes.
Why don't, as I call out your name, you just introduce yourself, and it's in no particular order, just the way it happens to show up on my screen. And you're welcome to turn your camera on and introduce yourself as I do that. So Nikolai?
Yes, Nikolai Olidin with Ethos Engineering.
Owen?
Owen Mills with Wilson and Company.
EG?
Morning,
CG
Randy
with
Dunsey.
the
Oh, I'm sorry. I thought you
Oh,
said
sorry.
Randy. My bad.
EG.
Yeah, CG with Wilson Engineers.
Okay. And Jen?
Jennifer Toss, McDock.
And Randy?
Randy Dunsey McDuck.
And the other Jen?
Hi, Jenny Bixby with AECom.
Justin?
Justin Rice, ACEC, Arizona.
And lastly, our speaker, April.
Hello, I'm April Wire with McDOT.
Well, we're glad to have all of you here. And April, we're excited to have her today. She'll be presented on the Loop 101 Mobility project, a little different than the connected vehicle thing. It was, I think we had a little miscommunication there between me and Justin, or me and Amerigo, but we're excited to have her. You know, April and I were chatting earlier. She is a native of Missouri and went to Missouri University of Science and Technology. I don't think anybody else, if anybody else here went there, that would be quite the coincidence. But before coming to McDOT, she's been at McDOT for about 7 years. Is that right, April? Close to that. And before that, worked in Kansas for the city of Overland Park and for Douglas County. So we're excited to have her today, and we'll go ahead and turn the time to April.
All right, thank you for those kind words. So today we were going to share the Loop 101 Mobility Project, and there is a connected vehicle aspect to it. So tying that in a little bit, we've been working on this project with our partner agencies for quite some time now, but we've made a tremendous progress in the last couple of years. So we wanted to go ahead and share some information on that. And so to lead it off, we got this grant in 2017 for ATCMTD. So it's a very long acronym, but it stands for Advanced Transportation and Congestion Management Technologies Deployment Program. So FHWA, ADOT, and McDOT went together and proposed for a grant for $6 million in federal funding to address congestion challenges for coordination of event management and incidents as vehicles depart on the Loop 101 corridor onto our surface streets. So ATC MTD program is under the FAST Act and is focused on helping organizations install advanced technologies at large scale. And so it is used as a national model to improve safety and reduce travel times for drivers and transit riders. And so on this slide, you'll see a lot of our partner agencies that are included on here. We've done a lot of work with these regional partners through the ACEC Regional Partnership, really focusing on advancing technology and operations along our corridors. And so this slide summarizes our regional partners, and you can see that there's a lot of regional partners from the upper levels of management to the operational folks in the TMCs. So we are really trying to engage a lot of different levels across our region to address different gaps and needs as they integrate into corridor management and strategies. So as we move from the space of integrated corridor management, we are really focusing on technology, and technology is really advancing for us in transportation. And so we understand that our strategy for corridor management is changing because of this technology underway. We are quickly moving from a state of being reactive with isolated operations to proactive, where systems are adapting, integrated, and connected. But before we truly are in that proactive state, we recognize that we are resting in this active state where we are actively coordinating with our partner agencies, managing our ITS devices and traffic signals through centrally managed software, and operating our corridors really on a time of day basis, instead of really focusing on those ever-changing, non-reoccurring events that happen on our freeways. And so through this project, we're hoping that we can be in a state where we're really in that proactive operational strategy for managing our corridors. And so integrated corridor management is a different way of operating our network. Rather than agencies really focusing on their individual assets, the corridor is viewed as a system comprised of many different modes, from freeway, arterials, and transit. And so we're trying to marry that into one system with the goal of providing seamless and reliable experience for the drivers. Because as agency as drivers cross jurisdictional boundaries, they don't recognize that they're going from the city of Surprise into McDOT, into Peoria, and so on and so forth. And so the Loop 101 Mobility Project is really broken up into several project elements. There's 5 key ones that I wanted to focus on today. The first one being Freeway Interchange adaptive ramp metering. The second one being focused on the State Farm Stadium in Glendale, deploying adaptive traffic signal operations for special events. We also have another component that's focused around the Scottsdale Trolley transit priority and connected vehicle deployment. We have a fourth one focusing on traveler information and mobile application. And the bread and butter of this project is the development and deployment of a decision support system for integrated corridor management. So all of these projects are really key in this Loop 101 mobility program. With the $6 million, we're actually really able to stretch those dollars kind of far, filling in some of the gaps with projects that are already coming down the pipeline from the local agencies, and their promise to deliver those projects in a timely manner to help facilitate the needs that are needed to make these 5 projects a reality. So we'll talk about the Freeway Interchange adaptive ramp metering projects first. And so right now those projects are led by ADOT. Adaptive ramp metering has the capability of being installed alongside the existing freeway projects as they're going on. And so a little bit more about the various locations. So right now, the focus of these construction projects are around Pima and Price Road interchanges. And so right now they've been very active in installing adaptive ramp metering, taking the technology that they did with their pilot deployments and advancing them onto the interstate around Pima and Price Road. The approach for ICM and the decision support system is that the adaptive ramp metering system will feed the decision support with data, and the adaptive ramp metering system will actually run independently from the DSS system, but it's kind of a chicken and egg type situation where the adaptive ramp metering system will feed the data into the DSS system and go into circular pattern. So they're actively in that deployment stage right now, filling in as many gaps around the Loop 101 corridor as they can, but really focusing right now on the east side of the valley, making sure that the system is fully operational and fine-tuned before they deploy at other interchanges. So the second project is really focused around the State Farm Stadium, home of the Cardinals football team. In that area, we're deploying adaptive signal technology, really focusing on special events in that area. There's been a dozen signals that have been identified as being high priority locations where the partners at Glendale really view those intersections being very key for incident management and special events. So the adaptive signal control technology system will be deployed at those intersections. The goal is to have the system up and running before the 2022 football season, which is right around the corner this fall. And the ultimate goal is to be able to use the system to support the Super Bowl that's coming in 2023. And so we really want to improve the ingress, egress flows of traffic, focusing on reoccurring events related to the Cardinals game days with assigned parking and whatnot, and just, certain routes that people take. And as we advance with this system, we really would like to see the system really focusing on reoccurring events, because that's where an adaptive system can really shine. With predictable timing plans, it's not really necessary to have a adaptive system, but when you have unpredictable conditions is where you can really see an adaptive system really shine. And so right now, we've completed the procurement of the actual system that closed back in February. We've had our kickoff meeting, and the vendors and contractors are actively working on installation right now. The anticipated turn on of the system is actually late June, which is, about 60 days out right now. So this project is really accelerated, trying to meet the deadlines of being turned on and fully functional this fall. So we are really excited about this one. This one in particular, we've been able to take a lot of the work that we've done with adaptive signal control technology just in our region and our knowledge, and really accelerated this. Our partner agencies are very comfortable working with this technology because we've piloted it, we've expanded it. They really understand what the capabilities are. So this one is moving quite forward aggressively. So another portion of the project is related to connected vehicle applications. And so building off of, our experiences with ITS devices and just technology in our region, we've taken the work that we've done in the Anthem test bed for connected vehicle technology, and we're going to be deploying that here along the Scottsdale trolley route for connected vehicles. The goal is to really use the applications that we've already tested on our test bed in Anthem and take it here to Scottsdale for transit priority. And our goal is to expand it to other vehicles as we get more comfortable with this. So a little bit of background as far as Anthem, it is one of the early adopters for connected vehicle technology, recognized as a test bed by US DOT many, many moons ago. We are really focusing there using dedicated short-range communication devices. As we move forward, we're seeing new technologies come on board, but that's not stopping us from learning from our experiences and piloting connected vehicle technology in other places. So in Anthem, we're really focusing on multimodal intelligent traffic signal systems. We call it MITS. It's really for vehicle priority applications. So in using MITS, we're going to be using that for transit priority. And so as we've gone through the process of trying to identify what corridor makes the most sense around the Loop 101 interchange for the Scottsdale trolley route and connected vehicle technology. So we went out and had many discussions with City of Scottsdale to engage them and help them understand what the technology is all about. Through those efforts, we've gone through and identified Hayden Road as being the focus of the connected vehicle effort. 10 intersections have been identified that we plan on deploying connected vehicle technology on. The Hayden route was chosen because it's a key corridor for the Scottsdale trolley and also parallel to the Loop 101 freeway. And so as part of the effort, we've gone through and reviewed the infrastructure at those 10 locations, really trying to understand what the capabilities of the existing infrastructure are mostly related to traffic signals, understanding how much room is in the cabinets, what kind of controller is out there, if any modifications need to be made to the equipment, how it's connected to the network so that people at the TMCs can remote into the systems and really operated in real time. And so through this exercise, we were able to identify those gaps and come up with a strategy to address those needs. In this field investigation, we also took a look at where the trolley stops were to make sure that they were in close proximity to the traffic signal so that we can tether off of those locations. So we also took a look at the Scottsdale trolley vehicle. This was my first time last year, honestly, being in the Scottsdale trolley. It's actually kind of a neat application that I encourage you to get on one day when you have really nothing else to do and take the trolley to Old Town to Hayden Road just to see what it's like. We wanted to see how the setup was. There's a lot of already GPS intelligent type systems inside the trolley vehicle right now. So we wanted to see where we could install our connected vehicle onboard units on the Scottsdale trolley, understand where we can connect to power and how we can integrate into their existing clever API system that's really used for GPS locating and understanding where the trolley is along the route and understanding if it's delayed on the route as well. So through this Loop 101 mobility project, we are also getting 600 onboard units through USDOT. A portion of those onboard units will go towards this project, integrated onto the Scottsdale trolley vehicle. A large portion is going into fleet vehicles, focusing on MCDOT and our partner agencies, and a portion is also going into our Anthem community for volunteers as well. So through this effort with 600, we will have a very large penetration of connected vehicle technology on the roadway, talking between the vehicles and the infrastructure that's on the road. So it'll give us huge data sets to understand how our connected vehicle applications are operating in a real, not real life scenario, but a very, very dedicated scenario where we have a lot of market penetration. And so as we've gone through this effort to understand the CV readiness, we also understand that connected vehicle technology is ever changing. Right now, our deployment is really focused on dedicated short range communication radios, but as we move forward, we see that CV2X type applications using 5G technology are coming on the horizon. So we're taking those things into consideration as we go through and spec out the equipment that's being purchased for this integration. And so another component that is crucial to this project is the integrated traveler mobility application. And so this one is really a mobile app intended to be used on smartphones or in vehicles through Android Play or Apple Play. We're looking at how we can connect the information for the Loop 101 to travelers on the roadway as incidents come up to get them, serve as an alternative route type solution for them. We understand that There's a lot of partnering involved in this. There's a lot of good opportunities for us to do public-private partnerships, and we anticipate those future conversations happening very shortly. This is one of the last probably milestones for this project, so we haven't really kickstarted this yet, but applications are changing every day, new ones are coming out, so that's why we really want to lean on our partner agencies in the private sector to help us come up with a solution that really is has a far reach for the traveling public and one that is readily used by many. And so I wanted to talk about the decision support support system a little bit. This is a large portion of the project. And so the focus on this is really the development and the implementation of a DSS system to support integrated corridor management. And so at the heart of this diagram is that decision support system. I did want to point that out. We envision the decision support system as a network of engines that can predict travel conditions for congestion. Using real-time data inputs and predictive modeling, the DSS system can provide drivers with information, including best detour routes when slowing traffic due to crashes occur or disabled cars ahead, to give them an alternative. So we've really done a lot of work in the last decade related to ingesting data into our regional archive data system that we refer to as RADS. So at the core of the decision support system is this data hub, RADS, that we are lucky that we already have established in our region. So right now, RADS is ingesting a significant amount of regional traffic management data. On the left side of the screen, you'll see all the data inputs that are going into RADS. So you'll see that we have CCTV camera feeds, travel time data, event data coming from our 911 dispatching centers, and signal data. And in the middle, you'll see our engines are depicted on there. All this data goes into processors that process the data and actually turn that data into information. Data sets are great, but until you can interpret what it really says, it's really hard to work with. And so that's why we spend a lot of resources on making sure that these engines are functional, operating very efficiently, and producing outputs that users can really use. And so after that data is processed, the information gets pushed to systems like AZ511, where it's displaying construction data or road closure information. We have processors that are pushing the travel time information to the dynamic message signs. We have other integrations that it's pushing traffic signal data and making those into performance metrics so that our staff at our traffic management centers can really look at those charts and performance measures and make very educated choices on if there's an issue out in the field, how to best address it. So we're really relying on RADS as being that foundational element to feed the data into our decision support system. And so just a quick summary of some of the tasks that are associated with each one of these projects. You can see with the ICM decision support system, there's a lot of planning work that happened on the front end. We've completed our operations plan that really describes what each stakeholder's role is. We are in the process of completing the concept of operations for the decision support system and the high level requirements that will really spell out at a very high level of what the system is capable of doing. We are planning on releasing an RFI and procuring a designer to really spell out what the system requirements will be, but we have defined what our high level requirements are based on interviews and conversations that we have had with our partner agencies on what they see as being important as we move forward with this project. For the Glendale adaptive traffic signal system, again, we've already gone through the procurement process and they're in the installation phase as we speak. And then for the adaptive ramp metering project, that's in place right now, going through our ADOT construction projects. With the connected vehicle pilot that's happening in Scottsdale that is underway as well. The next step for that one is really to come up with a plan for integration with the city of Scottsdale. And the integrated traveler mobility app is in the preliminary concept of operation stage. And so just a quick summary on the schedule of this project, you can see that we started in 2020. Although we were awarded this grant in late 2019, it took a little bit of effort to get the administrative side of the project going, but we are in full swing right now. You can see those stars represent milestones that are upcoming, and many of those stars are beginning or, have a significant importance in late 2022 and 2023. So those are quickly approaching as we move forward. And so when all this work is done, we're anticipating being complete in 2026, which is still a ways down the road, but I think we still have quite a bit of work to do, but we also recognize that we don't want to rush through this as well, because we want to actually meet the needs of our regional partners and make sure that the longevity of the system will be in place as we move forward. And so we recognize that this is probably just the initial phase for our decision support deployment and our ICM effort. I think there'll be many phases as we move forward with this project that go past 2026. And so just some next steps that we're anticipating coming on very early is an RFI being released for understanding who in the industry is capable of designing and building a decision support system. We understand that it's a very niche community out there, but we want to have a better gauge of what's going on in that space. And so that will be released in late May of this month. And then the adaptive system in Glendale is anticipated to be turned on in late June of 2022. We're right on track for that one again. And then in the summer of this summer, we'll be working with Scottsdale and coming up with a plan and probably start implementing some of those connected vehicle devices out on their infrastructure and getting that effort going. And so with any great project, there comes leadership from the top. We're very lucky to be well supported by our executive governance team that's led by Jennifer Toth from McDOT and Brett King from ADOT. So we want to thank them for their support. And then on the project management and technical side, we have many leaders coming from the ADOT side, the McDOT side, Federal Highway Administration, and also our general consultant that's helping us push some of these efforts forward. So we want to thank them for all their collaboration and drive to deliver this project. And so I will turn it back over to the ACEC team.
Thank you, April. Appreciate that. Does anyone have any questions for April? I have one. Or maybe more than one. You talked about the adaptive signal control over there with the Cardinal Stadium in Glendale and how that was going to function. And you said that it's that it's good if it's an unpredictable situation. That's where adaptive signal control really is most effective. But it's also, you said, good because it's a recurring event. So when you have a recurring event like the football games, are these also an unpredictable event? Are there different traffic patterns? And how does the adaptive signal adjust to a one-time every 2 weeks kind of an event? Because normally when I've thought about adaptive signals, I look at them relative to kind of rush hour type conditions or maybe weekend traffic kind of conditions, but this is really an isolated once a year, 8 times a year, maybe 9 times a year kind of an event that this is adjusting for. How does that work, and why is it better, or why is that an unpredictable yet recurring enough event to make adaptive signal a good idea there?
Right. So that's a great question. So in Glendale, they manage the Cardinal Stadium very aggressively. They have a lot of mega events coming through their area. And so I think pre-COVID, they were having at least 12 events a year that were considered mega events on top of their regular, NFL season that goes on. And so pretty much you're talking about a special event with a large attendance coming through once a week, essentially. So they've streamlined their processes quite aggressively. And so with their parking passes and whatnot, their traffic is actually very predictable when it comes to special events because they have such a great process down. So that's why in their situation, they've done a good job of mitigating how traffic flows on their roadways right now. With the adaptive system coming in, we see that as being an add-on for them, that right now they have a lot of uniformed police officers standing at those corners, manning those traffic signals. So with the adaptive system coming in, it would be good because it starts with these pre-timed plans. You set it, and then every time an event happens, it learns from it. It makes some adjustments every time, that, you turn on the special event settings and whatnot. So each time it goes through iterations and learns from what the traffic conditions were like the time period before. So in that instance, it's good for, predictable type movements, special events like that, where you kind of know where people are coming from, what times people are entering into your system and what time they're leaving as far as ingress and egress. It's usually like, a couple hours before the football game, a couple hours after the football game. So in that sense, it's very predictable. For if you have a system that's very, very well timed, then, you kind of don't really need an adaptive system, honestly, because when those cars are going to get there. But the case around the Cardinals Stadium is because they have so much special events going on that sometimes they are kind of unpredictable. I think for the football games, they have it down to a T. They know where people are parking. They're assigned parking passes by color. They know the volumes that are coming in. So it's more predictable. But in an event where a football game is going on and there's a crash on the Loop 101 interchange, that's where the unpredictability comes in. And that's where the adaptive system can really thrive. Even though it's learning using some pre-calculated measures, it does have the capability of every 2 minutes going in and adjusting based on the demands that are out there on the roadway. If we pre-program it to operate a certain way and, a crash happens on the freeway and even more traffic is being diverted onto the surface streets, I think that's where we'll really see the adaptive system thrive.
The other question I had, I know that we hear a lot of talk about these new technologies as maybe being some degree of a panacea to capacity concerns that we have on our roadways, wherein, you hear people say, well, we can't just keep adding lanes forever. Right away gets more expensive. We can't continue to do this. We're going to have to look to technology to enhance our capacities on our freeways or whatnot. So when this team is looking at the Loop Mobility Project as a whole and all the different things that you're looking to do around it, is there a expected capacity increase by percentage or by level of service that's expected to derive from all of these efforts, or is the effort not far enough along yet to know exactly what the total benefit's going to be?
Yeah, so we're not far enough along to understand the complete story yet. We have done some initial efforts working with our partners at University, ASU, Arizona State University, to do some modeling efforts. They're more at a macro level than a micro level, but I think it represents what could happen on our surface streets related to pushing a huge influx of traffic, using some inflated numbers and whatnot to give us an idea as far as level of service and performance of our signals. But we haven't gone down to the micro level to truly understand what do those volumes look like. I mean, if you're taking freeway volumes and dumping them onto the surface streets, I think partly the idea is that, with technology like Google Maps, people are going to find their way through. But at the same time, it's a huge influx of traffic when you're taking them off of the freeway and putting them onto the arterial streets. We need to have a strategy in mind to kind of move them through and understand what those patterns are, but we don't have their predictions, I guess.
Any other questions for April?
I have a question. This is CG. April, in all these modeling, how does the current situation play into your modeling and traffic projections? Like current situation, by current situation, I mean the COVID impact on people's behavioral changes in terms of coming to the office or working from home and things like that? Is that, or is it a temporary situation where we could probably deal with this as a temporary situation for the next few years? And so I just was curious if our traffic community was taking that into account at this point.
Right. So our partners, we've had a lot of conversations regarding that, not just related to this project, but everything that goes on in our transportation world. We've worked with our partners at MAG quite a bit to understand what those traffic volumes look like now versus pre-COVID. They've done lots of surveying of data to understand that. And so right now, the story that as we understand it, is that traffic volumes are almost back to what they were pre-COVID. I think we've kind of started to see the normalcy that is the post-COVID conditions. I don't even know if I can say that we're in post-COVID conditions. I think it'll go on for quite some time in the sense of, hybrid work schedule models and whatnot. And so we've kind of seen that those trends flatline. They're very close to what they were pre-COVID, but we're still in a recovery state. And I think thinking about systems like these, because traffic volumes and patterns are constantly changing, that's where they can really thrive. Because if they were very predictable, then we can continue to operate the system as we are today. But as we move forward, I think we'll continuously see these traffic volumes changing, patterns changing, new development coming in. Like Phoenix continues to be one of the fastest growing regions in the United States. I feel it every day driving down our roadways, that I feel like our streets are super congested. So we're trying to do our best to come up with solutions and be proactive in handling the situation, not only related to special events or incidents or anything like that, but just the changing field of what our transportation systems really are.
Thanks, April.
April, I had a quick question. You had said, I think 600 onboard units that are going to the Trolley and up in Anthem, correct? Are they going on other transit buses or?
Yeah, so we developed a pretty extensive plan on how to split up those 600 units. So a small portion is going to the Scottsdale Trolley in relation to this Loop 101 mobility project. We're partnering with Arizona State University, City of Tempe, City of Mesa to put some onboard units onto the ASU shuttle that runs between campuses. That's a fraction of them. The largest portion is going into McDOT fleet vehicles, and then some of our partner agency fleet vehicles, focusing on City of Phoenix, because they have a facility that's not too far away from where the McDOT main campus is located. And so we're partnering with them to deploy a few units out there. We have a few units that are dedicated to volunteer vehicles, like the general public and Anthem volunteers up in that area. So it's a mix, but the majority of them are focused on fleet vehicle deployment.
Got it. Okay. And then all that information, that's a lot of information. It all comes back into your system to just further.
Right. Okay. So we've never had that much market penetration before, because so connected vehicle onboard units and vehicles coming from the manufacturers are few and far between nowadays, and the space is just continuing to change. So I think that this exercise of the large number of deployment into actual passenger vehicles and fleet vehicles and those data sets coming in will really help us understand what is our system really capable of, what are our gaps, because we've never had that much data come through our connected vehicle intersections before.
Yeah, that's pretty awesome.
Okay, any other questions for April? All right, well, thank you everyone for participating. Again, we won't be meeting for the next couple of months. In August, when we come back again, we expect to be talking about the new tip and what's going on with that. That's our tentative plan, so you can look forward to that. And if not, have a wonderful summer. I hope you take this time to go and travel and do something great now that we're kind of past some of this COVID stuff. I know our family is. So I hope you are too. And we'll see everybody in a couple of months.
All right, thanks, everyone.
Thank you.
Bye.
Thanks, everybody.
Thank you, sir.